Hey guys, I wanted to go over a few problems from the equations and inequalities, just so that you can use those when you are trying the rest on your own. This is from the first page, number 2. The nice thing about a problem like this is that you can narrow things down, and sometimes you can narrow things down all the way to the answer. So for example, when you look at this problem, or this answer, you notice that it's got filled in circles. So you notice that, so you know that that means that the symbols should have an equals in them. So we can automatically eliminate those two options because neither one of them has an equals. And then since they are pointing out, then that's typically an or. It's either this graph or that graph. All right, and since it's an or problem, that means it should probably be the greater symbol. All right, because remember, less than makes a sandwich where you've got two ends and then you've got the middle. So it looks like it should be this one just from using our symbols. And then just to double check, we would remember to solve. 1 is the exact same, greater than or equal to 2, or the opposite of that, which would be 4x minus 9 is less than or equal to, switch the symbol, a negative 2, because that's the opposite. All right, and then when you solve it, you get 4x is greater than or equal to, pardon me, 11. So when you divide by 4, you get just under 3, which is 2.75. And if you notice, that's just under 3, that's 2.75. Or, when you solve this side, you get 4x is less than or equal to 7. When you divide that, you get just under 2, which is 1.75. And if you notice, this is 1.75, and it's going to the left. So less than is pointing to the left, greater than is pointing to the right. So this is the right answer, but really, because of our symbols, we can narrow it down, and so we just kind of double-checked and confirmed our answer for that one. Let's see, what other ones? The next one, number 3, we have right here. You can do the same thing. You can narrow down your answers, but then you do have to solve it. And just remember that when you do this, here, let me move it there so it's a little bit easier to see. All right, just remember that when you do this, before you set up your sandwich, because it's less than, you want to add your 1 over. So when we add our 1 over, we get the absolute value of 2x minus 3 is less than a 4, because I added it over. And remember, always check to see if it's no solution. So it's less than a positive, which is perfectly fine. Whenever you take absolute value, remember it either needs to be 0 or a positive number. So then we do solve it from there. Less than makes a sandwich. We have a negative 4 on one end, a positive 4 on the other end, and in the middle of our sandwich is 2x minus 3. So since this is our setup, that means our answer is going to be one of these two. Neither one of them are ors. All right, so it's either A or B, and then we just solve from there. Pardon me, add your 3 over, you get negative 1. Add 3 over here, you get 7, divide by 2, and that's where the fractions come in. So negative 1/2 and 7 over 2. So use the symbols to help eliminate some of your answers. Let's see. I don't believe that there were really that many other questions. Number 4, you'd use the same idea. Greater would point out. 5, that's less than, because it's a sandwich. So you just kind of use your same rules. Number 6, just remember there's 2 answers. One's positive and one's negative. You equal it to positive 7 and negative 7. So you get 2 answers. None of these happen to be no solution. But just remember, if you were to ever get the absolute value, let me use my hands, the absolute value is a negative number, it would be no solution. Does not exist. You might have the empty brackets. Just remember, you cannot solve. You can't take the absolute value of something and get a negative out. So just be aware of that in case they were to try to trick you. Another question we had in class, I remember, which I think is a really good thing to review, is on the next page. So when you go to the next page, we have this right here. All right, which is a perfect question to review because there's a bunch of options. You could use your calculator to solve, and when you use your calculator, these solutions, it's the same thing as zeros or roots. So any of those words all mean the same thing. You would look on your calculator to see where it crosses the x-axis. Some people wanted to factor it, which is perfectly fine. When we factor it, what multiplies to negative 16 and adds to 6? And people realize that's an 8 and a negative 2. But be careful, these are factors. They are not solutions. So that means the factors are x plus 8 and x minus 2. So remember, solutions, zeros or roots, they are the opposite of these numbers. So since this is a positive 8, that means the solution is a negative 8. Since this is a minus 2, the solution is a negative 2. So don't accidentally take the factors, which is what you're doing when we do our x, and just put them straight into the answer. Factors and solutions are opposite. So just keep that in mind because you're doing all the right work. So just make sure that you're careful as to what it's asking for and what it is that you are finding. There really weren't very many other questions on this section. Just remember it should always equal 0 whenever you're solving. Let's see. I think we might have had a question on number 2. So number 2, okay, it's asking for solutions again. So if you want to make your x, all right, remember it needs to say equals 0. So really we should be using x squared minus 4x minus 8 equals 0. So then if you want to think to yourself, okay, well what multiplies to negative 8 and negative 4? All right, but unfortunately, there's not a pair. So since there's not a pair, that means that it won't factor. It means it's probably a fraction or a decimal in your calculator. So we really should turn to the quadratic formula. So when we turn to the quadratic formula, we get the opposite of b, so that's 4 plus or minus the square, b squared. So I'm going to go ahead and write 16 minus 4 times 1 times negative 8 over 2 times 1, which is just a 2. All right, remember, put that into your calculator. That's actually 16 plus 32. So in your calculator, you should get a 48. And then this is a square root that you have to simplify. So let's go off to the side and we ask ourselves, what are the perfect squares in 48? Well, that's 16 times 3. All right, that's 16 times 3. So I square root 16, I get a 4 out. So right now I have 4 plus or minus 4 root 3, because the 16 square roots out, the 3 is still left, all over 2. And then these 3 numbers all divide by a 2. So that's why it becomes 2 plus or minus 2 root 3. So that's where that comes from. You have to plug it in, you have to simplify the radical, and you have to reduce the fraction. All right, now if you had used your calculator and maybe estimated some decimals, you could have found the decimals 2 plus 2 root 3 and 2 minus 2 root 3, and those decimals are what actually match the decimals on your calculator. They don't cross at nice clean places, so we could eliminate that. We did that when we reviewed it in class, and it's not imaginary because the curve does cross through. So you could use, if it's multiple choice, you could use the reasoning of eliminating these in order to get to this. But the mathematical way is following through that quadratic formula. But again, in the calculator, it doesn't cross at 4 and 2, doesn't cross at negative 4 and 2, and it wasn't imaginary. Imaginary would be above or below the x-axis. So elimination also gets us there. All right, let's see, what else? All right, I didn't see too many I don't remember too many other questions on this. I think you guys, this was one of the strongest areas of most of you guys anyway. So I think I remember seeing a question on number 1 on the 3rd page and number 3 on the 3rd page. But other than that, I don't remember very many other questions. So let me do a few more. There's number 1. Oops. All right, there's number 1 from the 3rd page. It is more solving, but it's not quadratic. So in this case, it's actually, you could say to yourself, I need to get, let me scoot it down. You could say to yourself, let me get a common denominator. But because it's just 2 fractions, one big fraction on the left and one on the right, you really can just cross multiply. So if you cross multiply, you get 8x plus 4 equals 3x. Okay? Or you could say, let me multiply both of these by 3. That's where you get 3x. Let me multiply both of these by 2x plus 1. That's where you get this. So whether you get a common denominator or whether you cross multiply, you're going to get the same answer. Subtract your 8x, you get negative 5x. Divide by that negative 5, and you get negative 4/5. All right, so just as a heads up, that's how that one would be approached, okay? Number 3 on this page was another question. You don't have to cross multiply because the denominators already match, so you don't have to get a common denominator. Remember, if they match, you can just throw them out. If you want to multiply both sides by x, it will eliminate those denominators. So really we have 3x squared minus 2 equals 6x minus 2. All right, now in one of the classes we talked about how you can actually use your calculator to solve this. So I'll pull up the calculator, but while that's pulling up, we'll also solve it algebraically with our numbers. So here's the calculator coming up. All right, so algebraically, we could solve it this way. We would say, all right, let me make sure it equals 0. If I add 2 to this 2, that goes away. And then if I subtract 6, I get 3x squared minus 6x equals 0. So there's a few options. You could put this into the calculator and get zeros. You could also factor it. Pull out an x, you get 3x, pull out a 3x. You would get x minus 2. And then each of these equals 0, so 3x equals 0, so x equals 0. Or x minus 2 equals 0, so x equals 2. So this is our algebraic way. And then we need to decide, okay, well, which one is it? We'll talk about that in a second. Graphically, we are used to going to y equals, putting this in, 3x squared minus 6x, 3x squared minus 6x. All right, when we look at the graph, it's crossing at 0 and 2. And that's the same thing as 0 and 2. All right, but then another way that you could do this, you can actually do this all the way back even, well, you could do it all the way back at the beginning. I would go ahead and drop the x's. So if you say this equals this, you could actually cut it in half and say, well, let me make this my first graph. Let me make this my second graph. And then where they cross, it's a system, is actually the same x's you'll get for these other methods. So in case you were to see something like this, you don't even have to do any of this. All you have to do is put this side in, 3x squared minus 2. The other one is 6x minus 2. All right, so this is the left side and the right side, and where those cross will also give us the same answers. So there's the first one, there's the second one. So where the x values are, where they cross, that would also be a way to give us answers. So this is just, it kind of reviews systems along with equations. So we think that the answer is 2. So when x is 2, they do match, so that's where they cross. So this method is telling us that x is 2 when y is 10, but we just care about the x value. And then when we look a little bit more, there's 0. They do match, so x is 0 when y is -2. Again, we don't really care that much about the y's, but these two x values are the same as these x values or the ones we did when we set it equal to 0. So there are a bunch of different ways you could solve this. With an equation, with getting equal to 0, or with having them cross each other. All of them tell us that the solutions are 2 or 0. But unfortunately, we either have to choose, is it 2 or is it 0? And the reason why we choose 2 is because the original equation has a denominator right here. And since it has a denominator, remember, what's the one thing we can't have in the denominator? We cannot have a 0. So because you cannot have a 0, you cannot divide by 0, all of these zeros, no matter how we found them, are out. And that's why it is just 2. Because when you go back to the beginning, that 0 causes a problem. It's extraneous. It's an extra answer. Okay? All right. Anything else? Okay, number 5 on that same page, I think would be a great way to use your calculator. Instead of, let's see, here it is. All right. All right, number 5 right here. Instead of trying to solve it, you could get a common denominator of x, multiply this by x, that you don't need that one, multiply that by x. All right, you could actually use the idea of the calculator, where do they cross? So you could say, this is one side, this is y1, you could say this is y2, and then where do they cross one another? So let me show you that one more time. This is actually something that we didn't do in class. It's just a calculator trick that I've seen before, but I hadn't clicked until towards the end there. So if you want, you can put that in, which, if I clear this out, that's x minus, and we can put parentheses around this fraction, 25 divided by x. All right, oh, excuse me, x plus 25 divided by x. So let me go through, let me change that to a plus. And then the other one is just equal to 10. So this is one side, this is the other side, and where they cross are our solutions. So we move it over. When we graph it, there's x equals 10. And unfortunately, this looks like it's above it or outside of this, but our table will give us our solutions. So let's look at the table. Where they repeat, so we're looking for where this is 10 and where that is 10. It looks like we're going negative, so let me go the other way. All right, there's positives. We're getting close to 10. And if you notice, right here, it is 10 and 10. So x equals 5. When y is 10, you don't really care about the y value. That's just where they match. So this is the answer. So place your answer in the box. That would be a 5. You could solve it the long way. Let me do that for you real quick. The long way would be multiply this by x, because I would need an x on the bottom. That's already good. Multiply, oh, that's a 1. Multiply that by x. You get x squared plus 25 equals 10x. Okay, you can throw out the denominator now. Move your 10x over so it equals 0. Make it a trinomial. You could solve this by factoring, or you could put it into the calculator. If you put it into the calculator, it crosses at 5. So, what was it? X squared minus 10x plus 25. If you look here, it only crosses one time. That's why there's only one answer, no matter how we did it, and that is at 5. So this also, the factor is this, but the solution is this, and it's a double root. Okay, that 5 stands for both answers because it only hits it once. So that stands for both answers from this x squared. So this is algebraic, and using our graph, you could have, again, treated them separately. Where do they cross? I didn't have very many other questions on much else. Maybe it's just because people hadn't gotten to the problems yet. A lot of the rest is using a system. Where do they cross? What's the x value? What's the y value? I can tell that there are maybe 2 other problems that I remember going over, or that you might want to go over. If you look at the back, this one, number 6. All right, number 6, there's a formula. The formula is r equals 2 times the square root of 5s. It says the length s in feet of the skid mark left by an automobile traveling r miles per hour can be approximated by this formula. If a car is going 80 miles per hour when the brakes are applied, about how many feet long would the skid mark be? So, if this is the formula, r equals 2 square root of 5s. All right, 80 is our rate. So we put, 80 in here. And you can do 2 things. You can either put this into y equals and look at where it's 80, or you could solve it from here. So algebraically, you get 40 equals, because I divided the 2 out. Then you square both sides. To get rid of the root, you get 1600. Then you divide both sides by 5. So you get s equals, I believe it is, 320 when you divide. That's how you could do it algebraically. You could really turn to your calculator quickly and say y equals. So instead of r equals, just make that a y. I'm going to put 2 root 5x in there. 2 square root of root 5 times x. The graph, I don't think we'll see it. Oh, there it is. Okay? But we want to go all the way up to 80. Okay? We want to go to where y is 80. So that's really high up there. So let's just go to the table. And if I go to the table, if I go to 80, okay, that takes a while. If you want to remember, table set is how you can set your table. And instead of starting at 1 or 16 or something, I'm going to start at 80, and it'll jump me straight there. So now if I go back to the table, if I start at 80, oh, sorry, that's the y value, that's the x value at 80. We want the y value to be at 80, so we are probably going to have to jump. So I would say put in 320, see if that's the y value is 80. Put in 410, see if the y value is 80. So, again, let me set my table at 320 instead. Now let me look at my table. Now, when y is 80, because I've just replaced that with 80, then the x value is 320, so it matches this. Okay, so you could use your calculator. It might take you some time. It might have been faster just to go ahead and solve. The last question I remember people having isn't the systems, it isn't the absolute value or anything like that. It was number 12 on this last page. So moving over here, it is this one, number 12. So number 12 says, What is the solution? Well, before you use the quadratic formula, which is obviously what you need for any answer, okay, I would still think of GCF. I would still try to factor because it'll make it easier. So the GCF of this trinomial is a 2. So if you divide your 2 out, it is going to make substituting into the quadratic formula a lot nicer. So now I'm going to use these for A, B, and C. So A, B, and C. And it's just going to work out a lot better. It's going to be easier to substitute 1's in instead of 2's, and then you don't have to worry about reducing. So the opposite of B is 1, plus or minus the square root. B squared would be 1 again. Minus 4 times 1 times negative 1, A and C, over 2 times 1, which is just 2. Well, this, when I put it into my calculator, just becomes 5, and I'm done. Okay? If you were to use 2, negative 2, and negative 2, you would get this, but then you'd have to reduce it all. Whereas when I did the GCF at the beginning, it's reduced, and that's why it matches that answer. All right, so hopefully that answers a bunch of questions. Hopefully you can use that to get through the rest of them, and you feel squared away with your equations and your inequalities, all right? Good work, you guys.